Go ahead and continue with yesterday's lesson. Your assignment was to finish this extra practice at home. I've had many of you ask me about question 11, and it could be just because it's the first one. I knew that there would be questions most likely on these two. I know there might be some questions here, but I also know that some of you did at least two of these. You don't have full credit on yet. And then I was hoping on this one that everyone would at least try it. It's not that bad. It just has a lot of words. Okay, so you got to read and go through it, which I know you can. So I'm going to show two different ways to deal with number 11. Okay, first way is the way I think most of you would have approached it, where you multiply by 2 on each side to get rid of that half. So it gives you x to the 5 halves equals 32. And then some of you, actually, I would guess most of you from there, and I'm going to slide it over here and write it down. I guess most of you tried to go back to your memory bank and say, hey, I know this, one of them's like a root and one of them's a power. Okay, remember the bottom is the root. That's the square root of x to the 5th. Okay, and that is equal to 32. Now remember, the square root is just index of 2 there. Okay. This is the square root. So the bottom number is always what root we're taking, and the 5 is here. Or if you wanted to, and our textbook actually shows it more like this. It shows with the 5 out there. Same thing. Same thing. Okay? So this right here, you could do it like that. That is completely fine. The next step would be then to take the 5th root of 32 or square 32. You could deal with either of these first. I would get rid of the root first. Excuse me. Thanks. So we'd have the square root of x is equal to the 5th root of 32, which we know as 2. Okay, so square root of x equals 2, and then square both sides, x equals 4. Okay? That is one way to do it. The other route, well, first, any questions on that? The other way to go about it, and what I honestly think is the easier method, I think it becomes less confusing with, I like radicals. I think they're totally awesome. Okay, but I'd like to use exponents. Okay, so x always yearns to be x to the 1st power. That's what it wants in life. Okay, so to be x to the 1st power, we'd actually have to raise this to the 2/5, or the reciprocal power, the 2/5 power. Okay, now by doing that, we can raise this, or we'd have to raise this to 2/5 as well. And what happens is these two things cancel. And we're left with x to the 1st, and x is a happy, happy, joy, joy x. Okay? And then we have 32 to the 2/5 power, which means the same thing as this, right? Okay? So the answer is 4. You could think of it as, well, what's the 5th root of 32? That's 2. Square it is 4. Okay? If you can get in the habit of using the exponents and just thinking the bottom number is my root, what root I'm taking, the top number is what I'm doing to it after I take that root, or before, if that's helpful. Usually it's helpful. It's easier afterwards. Okay? Then go that route. Yeah? You show me here in a while. Why don't you show me here in a while? Okay? All right. Any questions? Okay, number 11. I want you to, or number 12. I want you to tell your neighbor what, actually, I know what you did. Most of you did first. Subtract 28, right? Okay, 128. So, what did you do and what could you do now? Okay? Talk to your groupie about it. Okay. Can I have your attention, please? Hey, within 5 seconds of me asking, right? Okay, so we have 6x plus 10. We're going to raise this to the 3/7 power. Raise this to the 3/7 power. Now I realize that this is a new thing, and especially those who resist change, you're going to be like, I don't like doing it that way. I like this. Okay, think of this as this. Now, pause. I see about 5 of you staring at your Chromebooks. Usually they would be closed. If you don't have enough self-control to look up here. Eyes right here, please. If you don't have enough self-control to not pay attention to your computer, then you need to close it, or you need to go outside. Okay? Right now, you need to be focused up here. I realize we have them open because you're downloading something, but you've got to be more controlled than that. You're in 9th grade. All right? So, this right here, this 7th root of 128, if you want to write it like that, is that, and then cube it. Okay, 7th root of 128 is 2. 2 cubed is 8. 6x plus 10 is 8. Subtract 10. Divide by 6. You get x equals negative 1/3. All right. Cool. Hey guys, I realize we like this format. Please get used to seeing both ways. It'll help you out. Okay. Why do we have silly rules? No, it's not. It has nothing to do with math. Okay. Why do we have to make up silly rules? Yes. No. Have we not talked about this in this class? We make up silly rules for people who do silly things. Okay? Like on our Chromebooks when we shouldn't be, or having earbuds in when you're talking to someone, or playing with your phone during class, and then that's when the teacher says things like, hey, no phone, and then you go to your friends like, this guy's so stupid. Hey, you don't have phone. You can't use phone. Okay? Well, there's a silly rule, or a quote, stupid rule for people who do silly things. Okay? Don't do silly things. We don't have silly rules. All right. Hey, and just so you know, all through life you have silly rules. You'd be like, why do they even have that? Why do they have a sign on my chainsaw that says don't touch the saw while it's running? I mean, why would we have that? Well, okay, there's a reason. People feel like, oh, I didn't even know. Okay? Silly things. Okay? All right. Here we go. Number 13. Tell your neighbor what you got. Okay, time's up. My guess is everyone, I hope, subtracted 3 first, and then divided by -4. What happens when you divide by a negative? Switch the sign. Now, when we do that, we subtract 3, we divide by -4. Did anyone not divide by -4 or subtract 3 first? Did anyone square first? Okay, we'll come back to that here in a minute, okay? So, just so that we're clear, when we multiply or divide by negative, we flip the sign. All right? If you said right here, you're like, well, I'm going to go ahead and square both sides because I know I have to get rid of that radical. So I square it, and that gives me a positive 16. And then I square this side. When you square this side, what are you multiplying by? -4, which means you still have to flip the sign. Okay? So make sure you flip that sign, and when you square it, it's not as evident. Okay, I'm going to wait and square it afterwards. So that's what we've got there. We're going to square it now. That gives me x minus 1 is less than or equal to 1, and x is less than or equal to 2. How many got it? So you have half credit unless you have the other part of the answer. Okay, so what's the other part of the answer? I want you to focus right here. It's not plus minus. What do we know about the value inside the radicand? Can't be negative, which means it has to be greater than or equal to 0. So we have to consider the radicand here. Okay, by considering the radicand, we look at it and we say x minus 1 has to be greater than or equal to 0, which means x also has to be greater than or equal to 1. So you have two rules. You have x is less than or equal to 2, and x is greater than or equal to 1. So when I'm writing this out as a solution, okay, we have our compound inequality that looks like that. Our answer has to be in between 1 and 2, or include 1 or 2. Okay, it's got to be from 1 to 2. Now the question is, when does this have to be positive inside the radicand? Okay, maybe I'll change the question. When can the number inside the radicand be negative? What's that? No. Emma? Good. If it's an odd root, or if it's an odd root, okay? If it's an odd root, it can be a negative in there. So am I going to have to consider it here? No, it's an odd root. Am I going to have to consider it here? Yes. How come? Oops. Because it's an even root. Okay. Why don't you tell your neighbor what you got for number 14? Yeah. Yeah, I'll do 5. Okay, there it is. Total yay? There's the work for it. All right. Any questions? Okay, the next one. Next one. Haley, did you get it? Good? Yeah. Okay. Yeah, no. Okay. Go ahead and tell your neighbor what you got there. And if you didn't consider the radicand, you may want to think about doing it. Okay, there we got it. Total, yeah. It's not 65.3. It's 65 and a third. It's not 65.3 with a little bar over it. It's 65 and a third. Okay. Technically, we're not being technical. Yes? Question? No. Okay, and number 16. There is our solution. Okay, got to find first place, got to find second place, subtract the 2, it's 1.76 feet a root. Or feet. Feet a root. So, on 5.4 practice A, I want to take a look at problem number 18. So, I want you to go through that one on your own. Solve it up. All right, so hopefully you added 4, you got your 9. Divided by 3, you got your root x equals, or is greater than or equal to 3. You squared it, you get x is greater than or equal to 9. Good? Now, how many of you considered the radicand? That this cannot be 0. Is that true? Or, excuse me, cannot be negative. Okay, so did anyone put that answer as well? Okay, now, why would we not need this answer in this problem? Derek? Good. Yeah, your answer is already bigger than 9. It's not going to go any lower than 0. Okay? And in fact, if you put this answer, then you're implying, well, I guess this would be an and, so you're not really implying it, but you have a portion that I would question if you're thinking like there could be solutions between 0 and 9 that work. Okay? That cannot be the case. So we don't need to do that if your answer is already greater than whatever you get here. Does that make sense? If the answer, when considering the radicand, if your answer is already satisfying that, you don't have to put that part. Okay. Very good. Your assignments finished that page?
Just